Hi, this is Kumaravil. In this lecture, we are going to discuss about EIRP. EIRP stands for Equivalent Isotropic Radiated Power. EIRP is a key parameter in link budget calculation. Now, let us consider an antenna. Okay, consider an antenna A, right, whose gain is capital G. Now, let us find what will be the maximum power flux density at distance r from the antenna. Right, distance r from the antenna. This can be written as xi equal to g into e suffix s divided by 4 pi r square. Here g represent gain of the antenna and ps represent transmitted power of an antenna. Our case is A, okay, and r is nothing but what? The distance between antenna to the arbitrary place. Okay, so now let us proceed with an isotropic radiator. Isotropic radiator is an antenna which radiates equally in all the directions. It is a theoretical antenna. Okay, for an isotropic radiator, EIRP equal to G into E suffix S. EIRP stands for equivalent isotropic radiated power, which will be equal to gain of the transmitting antenna into power of radiated power from the antenna. Okay, so now generally this ARP will be represented in terms of decibels. Okay, therefore we can write the whole equation as ARP equal to transmitted power plus gain. So power in terms of watt and gain in terms of decibel. Therefore unit of ARP is decibel watt. Now let us consider a paraboloidal antenna. The isotropic power gain can be written as G equal to eta into 10.472 F into T. So here F represent the frequency and D represent the reflected diameter. Generally F, the unit will be in terms of gigahertz, and the reflected diameter generally it will be in terms of meter, and eta is the aperture efficiency whose typical value is 0.55. Okay, instead of if the reflected diameter, instead of if it is given in terms of meter, instead if they gave in terms of feet, then we can write the isotropic power gain G as eta into 3.192 F into D the whole square. If diameter reflected diameter in terms of meter means, then we can consider this equation for isotropic power gain. If it is given in terms of feet, then we will consider this equation. Okay, so now let us consider a problem. So in the problem, so they ask us to find the gain in decibels of a 3-meter paraboloidal antenna. Operating frequency is 12 gigahertz. They gave paraboloidal antenna, okay, 3 meters, that is diameter T equal to 3 meter, okay, and operating frequency F equal to 12 gigahertz. F equal to 12 kilohertz. Two values they gave, right? So they ask us to find the gain of the antenna. To find the gain of the antenna, either we should consider this equation or this equation. Okay. So now, what is the difference between these two equations? They are differ in terms of what? The reflected diameter. If it is given in terms of meter, we will consider this. If it is given in terms of feet, we will consider this. Okay. If we'll look into the question, so it is given in terms of meters, so we'll consider this expression. Okay, consider this expression. In this expression, the frequency they have given in the question, diameter they are given in the question, eta they have not given in the question directly, but we know the typical value of aperture efficiency is 0.5. So we'll consider all these values and substitute it. So eta is 0.55 and 10.472 into frequency is 12 gigahertz. So we substitute directly 12 in order to mention gigahertz, because generally frequency will be represented in terms of gigahertz only. and the diameter is again we represent. So we substitute only 3 because it is in terms of meters. Then we can compute it. So we'll get gain as 78,168. But in the question they have given, we need to find gain in terms of decibels. Therefore, we will take 10 log of 78,168. Then we will get decibel equivalent for gain. So decibel equivalent for gain is 48.19. Okay, thank you.